Mangaru's Tutoring Services, Mathematics Classes.
Fractions. In this video, we will look at shading fractions, equivalent fractions, addition, subtraction, multiplication, and division of fractions. Let's start with shading fractions. Shade a fraction. You can feel free to pause the video and attempt the questions if you like. I hope that you have the exercise. Here we have the answers, but let's discuss the answers. Half simply means 1 out of 2 parts. So we have a whole that is divided into 2 equal parts, and we must shade 1 part. Similarly, we are shading 2 out of the 3 parts for 2/3, 3/4, 3 out of 4 parts, D, 2 out of 5 parts, 4/6, 4 out of 6 parts. So you all have the idea. This is a really simple exercise. Let's go on to the other exercise. Equivalent fractions. So equivalent comes from the root word equal, which means the fractions are equal. In this fraction, we have a whole divided into 2 equal parts. For this one, we have a whole divided into 6 equal parts. So the difference is the number of parts that the whole is divided into. But we can observe that this portion is the same as this portion. So we can see that it can be equal. Okay, so let's talk about a half. So 1/2 is equal to how many? 6. So the whole is divided into 6 parts, so the denominator will be 6. So we are trying to figure out the numerator. So we check to see what numbers we have. So we are going across. So we have the 2 and the 6, so we have both denominators. So we check to see, is the number bigger? Are we going from a small number to a bigger number? Yes. So it's one out of 2 things we do with equivalent fractions. It's either we are going to multiply or divide. So in order to go from a small number to a bigger number, we must multiply. But multiply by how much? 2 times what will give you 6? 2 times 3 is equal to 6. So whatever we do with the numerator or denominator, we must do with the other. So for the denominator, we are multiplying by 3. So we must do the exact same with the numerator, multiply by 3. So 1 times 3 is how much? 3. So half is equal to 3/6. Right? In your answer, you don't need to put this in. That's for the working. Let's look at another example. So this one, I won't show the answers yet. We have 1/3 is equal to how many? 6. So we can see we are going from a small number to a bigger number. So we must multiply. How do we go from 3 to 6? We multiply by 2. 3 times 2 is equal to 6. Whatever we do to the denominator, we must also do to the numerator. So we also multiply by 2. 1 times 2 is 2. So 1/3 is equal or equivalent to 2/6, and we can see this here. We can see that this is the same size fraction or same portion of the whole. So it takes 2/6 to make up 1/3. Next, we have two fractions that are also equal. So this fraction on the left is made up of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 parts. So that's the denominator. And we have 1, 2, 3, 4 parts shaded. And that is equal to, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 parts, so the denominator is 8. So 4/16 is equal to how many 8s? So in order to go from 16 to 8, do we multiply or divide? It's a smaller number, so we must divide. We will divide by 2. 16 divided by 2 is equal to 8. So we must do the same to the numerator. Divide by 2. 4 divided by 2 is equal to 2. So 4/16 is equal to 2 8s. Let's look at the next question. We have 1, 2, 3, 4 parts. 1, 2 out of the 4 is shaded, so that's 2/4, and that is equal to, the denominator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And we have, let's try to figure out how many parts we need to shade. So 4 to 16, that's a higher number. So we must multiply 4 times, yes, 4 is equal to 16. So we must also multiply 2 by 4. 2 times 4 is equal to 8. So we must shade 8 out of 16 parts. Equivalent fractions. So for this exercise, we don't have any shading, nor do we have any visual aids. You can feel free to attempt the questions now. So of course we are trying to find the missing denominator or numerator for the equivalent fractions. So you can feel free to pause the video now and try the questions. Okay, so let's begin. I will do a few of the questions. So we are going from a small number to a larger number. So we must multiply. 2 times what will give you 4? 2 times 2. So we must do the same to the numerator. We must multiply by 2. 1 times 2 is 2. Next, 2 multiplied by what will give you 10? 2 times 5. So 1 multiplied by 5 will give you 5. Here we are also increasing, so we must multiply. 4 times 2 will give you 8. So 3 times 2 will give you 6. Let's look at some where we must find the denominator. It is a very similar approach we need to use. So 3 multiplied by what will give you 6? 3 times 2. So 8 times 2 is 16. 5 times what will give you 15? 5 times 3. So 8 times 3 is equal to 24. Now we are going from a larger number to a smaller number. So we must divide. 6 divided by 6 will give you 1. 18 divided by 6 will give you 3. Fourteen divided by 7 will give you 2. 21 divided by 7 will give you 3. Now I will display the answers. So feel free to make your corrections. Next, we have reducing fractions. In reducing fractions, we try to find a number that we can divide both the numerator and the denominator by the same number without getting a remainder. Or in other words, we try to find a number that both the numerator and the denominator is divisible by. So what can go into 9 and 12 without a remainder? So 9 divided by 3, we cancel it here and put 3. 9 divided by 3 is equal to 3, and 12 divided by 3 is equal to 4. So the answer is 3 over 4. There is no other number that can go into 3 and 4 without a remainder except 1, but we don't use 1. Number 2. What number can go into 2 and 4? Well, for starters, we know that 2 and 4 are equal numbers, so 2 can go into both of them. 2 into 2 is equal to 1, and 2 into 4 is equal to 2. So the answer is 1/2. 3. What number can go into 10 and 15? 5. 5 is the only number. 5 into 10 is equal to 2. 5 into 15 is equal to 3. So that would be 2/3. Right, so you can feel free to try the rest of the questions. Pause the video if you need to. So these are the answers. I hope that you all got all correct. If not, please make your corrections. Addition and subtraction of fractions which have the same denominator. So 1a, 1/4 plus 2/4. So if the denominator is the same, we simply add the numerators. So 1 plus 2 is equal to 3, so that's 3/4. B. 1 plus 3 is 4, so that's 4/6. Let's look at the subtraction. The subtraction is very similar. So the denominators are the same, so we simply subtract. 9 minus 4 is 5, 5/11. And similarly, 13 minus 6 is 7, so that's 7/16. Addition and subtraction of mixed numbers. So mixed numbers simply mean whole numbers and fractions combined. So we can add the whole numbers first. So 1 plus 2. So let's make some space here. 1 plus 2 is equal to 3, and 1/4 plus 1/4 is equal to 2/4. So that is 3 and 2/4. Now we can reduce this if we like. We can say 2 into 2 is equal to 1, 2 into 4 is equal to 2. So that's 3 and a half. 3 and 2/4 is the same as 3 and a half. B. 3 tenths plus 2 and 2 tenths. So we can add the whole numbers. 3 plus 2 is 5, and 3 tenths plus 2 tenths. So 3 plus 2 is 5 as well. So that will be equal to 5 and 5 over 10. Again, we can reduce this if we like. We can say 5 into 5 is equal to 1, and 5 into 10 is equal to 2. And that is what we normally do. We normally reduce. Let's look at subtraction. 2 and 2/3 minus 1 and 1/3. We can work with the whole numbers first. 2 minus 1 is 1, and 2/3 take away 1/3. So 2 take away 1 is 1. So that's 1 whole and 1/3. Three and 1/5 take away 1 and 4/5. So 3 take away 1 is of course 2, and we have 1/5 take away 4/5. Can 1 take away 4? No. So we must borrow from the whole. So if we have mixed numbers and the fraction cannot take away the other fraction, we need to borrow from the whole number. Now one of these wholes from here is really equal to 5. We can write it as 5 over 5. Any whole can be written in a way where the numerator and the denominator is the same. So 5 out of 5 means 1 whole, 4 out of 4 means 1 whole, 50 out of 50 means 1 whole. So we can take 1 whole from the 2, we will remain with 1, and we can carry over 5/5. So 5/5 plus 1/5, so some persons write it like this: 5 plus 1 is 6. So that is 1 whole and 6/5 take away. So 6/5 take away 4/5, and the 1 we carry over the 1. So 1 whole and 6/5 take away 4/5. So 6 take away 4 is 2. So the answer is 1 whole and 2/5. So let's try another one. 4 and 1/3 take away 2/3. So we don't have any whole numbers here. So we keep the 4, and 1/3 take away 2/3. So some persons make the mistake and say, well, 1/3 take away 2/3 is 1/3. They flip it around and say 2/3 take away 1/3. We cannot do that. So 1/3 cannot take away 2/3, so we must borrow. So if we take away 1 from 4, we remain with 3. And whatever the denominator is, we must carry that number across. Remember, whatever the denominator is, we can say 1 whole is 3 over 3. 1 whole is 3/3. So we just have to carry the 3 across here. So 3 plus 1, that's 4/3. Take away 2/3. So we have this whole number 3. 3 and 4/3 take away 2/3. 4 take away 2, as we know, is 2. So the answer is 3 and 2/3. So you can feel free to pause the video and try the rest of the questions. Feel free to make your corrections. Now we have addition and fractions with different denominator, solving these by using equivalent fractions. So 1/5 plus 1/10, we are not going to add the denominators if they are different. So don't make that mistake. What we must do, if we want to use equivalent fractions, we need to make 1/5 into tenths. How do we do that? Well, how do we get a 5 to become 10? We multiply by 2. So let's convert the 1/5 into tenths. We multiply the denominator by 2, and the numerator must also be multiplied by 2. So 1 times 2 is 2, and 5 times 2 is 10. So 1/5 is the same as 2/10. So now we have 2/10 plus 1/10, and that will be 3/10. Let's try another question. So this one, it's best to use LCM method for this one, so I will skip this one. Okay, let's take a look at this one. So instead of multiplying to make the smaller fraction equal to the bigger fraction, we can also divide. So we can work towards making 9 equal to 3. So we can say, well, 9 divided by 3 is equal to 3, and we will get the same denominator. So let's do that. 9 divided by 3, and we must do the same to the numerator. 3 divided by 3. So we will get 3 divided by 3 is 1, and 9 divided by 3 is 3. So now we have the 1/3 plus the 3/9 is also equal to 1/3. So that will be 2/3. Now notice we could have also reduced 3/9. We could have said 3 into 3 is 1, and 3 into 9 is 3. We would have gotten the same answer. Addition and subtraction of fractions with different denominators using the LCM method. What is LCM? LCM simply means lowest common multiple. So you can feel free to look at our video on multiples. Let's briefly revise multiples. So let's look at two numbers, 4 and 5. What are the first few multiples of 4? So the first multiple will be 4 times 1 is 4, then 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, followed by 20, 24, etc. The first few multiples of 5 will be 5 times 1 is 5, 5 times 2 is 10, 15, 20, 25, etc. So we understand what common means. Common we're talking about same. So we can see here that we have a common number or a common multiple, 20. So this is the lowest common multiple because there are no other common multiples before it. So 20 is the lowest common multiple of 4 and 5. So we will use that for the addition and subtraction of fractions with different denominators. So let's begin. We will find the LCM of 4 and 5. What number can 4 and 5 go into without a remainder? Or in other words, what is the lowest common multiple? Now if the numbers are really small, you can just multiply them and you will get a common multiple. May not be the lowest common multiple. So 4 times 5 is 20. So we say 4 into 20, or 20 divided by 4, is 5, and then 5 times 3. So again, new denominator divided by denominator. So 20 divided by 4 is 5, and then multiply by numerator. So that's 5 times 3 is 15. So what we just did there is made 3/4 equal to 15 over 20. Those are equivalent fractions. And then we add. We do the same for 2/5. We want to make 2/5 equal to a fraction where the denominator is 20. So we say 5 into 20, or 20 divided by 5, is 4, and then multiply by the numerator. 2 times 4 is 8. Now we can add 15 plus 8 is 23. So that's 23 divided or over 20. So for now we will leave it like this. Later on we will do improper fractions and mixed numbers. Okay, so let's look at another question. This time we have subtraction. So let's find the LCM. So this time I will take my time and list the multiples out. What are the multiples of 3? 3, 6, 9, 12, 15, 18, etc. What are the multiples of 5? 5, 10, 15, 20, 25, and the list goes on. So let's look for a common multiple. So we have 15 here and 15 here. So we can use that common multiple. Notice for small numbers we can also multiply the denominators. 3 times 5 is also 15. So 3 into 15, or 15 divided by 3, is 5, and 5 times 2 is 10. So 2/3 is equal to 10 over 15. Subtract 5 into 15, or 15 divided by 5, is 3. 3 times 2 is 6. So 10 minus 6 is 4. 4 over 15 is your answer. So let's take a look at number 5. Number 5 includes a mixed number. So I know that 1/8 cannot take away 1/3, so we will have to borrow. So this is a different type of question. So this time we will multiply the denominators. 8 times 3 is 24. 24 divided by 8 is 3. 1 times 3 is 3. 3 into 24 is 8. 1 times 8 is 8. So we have 3 minus 8. We know that that cannot. So, well, we still have to carry down our 1. We have 1 whole here. So 1 and 3 24ths minus 8 over 24. So what we need to do, since 3 cannot take away 8, we want to borrow from this. So don't bring across 1. That will be wrong. This 1 whole is really equal to 24 over 24. Right? Remember, our new denominator is 24, and the whole can be written as any number over the same number. So we are bringing across, so we borrow 1 from the 1, we remain with 0. We are bringing across 24. So 24 plus 3 is 27. 27 take away 8 is equal to 19. So that's 19 over 24. Feel free to pause the video and attempt the questions before I turn to the solutions. You can now pause and make your corrections. Mixed numbers and improper fractions. So remember, I said that mixed numbers are simply a whole number and a fraction, while an improper fraction is where the numerator is bigger than the denominator. So let's begin. Exercise 1. Convert the mixed numbers to improper fractions. So in order for us to do that, we must multiply the whole number by the denominator. So let's do that. 1 multiplied by 2, and then, so that will be equal to 2, and then we must add the numerator. So 2 plus 1 is 3. And now we put that answer over the denominator. So that's 3 over 2. So let's try that again. Whole number multiplied by denominator plus numerator. So that's 3 multiplied by 3. 3 times 3 is 9. And then 9 plus 1, we know that's 10. So we put 10 over the denominator. So that's 10 over 3. So we are simply writing the mixed number as an improper fraction. They are the same value, or they are equal, just in a different form. So you can try numbers 3 to 5. Pause the video if you need to. Exercise 2. Convert the following improper fractions to mixed numbers. How do we do that? Well, we must divide the numerator by the denominator. 7 divided by 2 is 3, and we put the remainder as a numerator. So that's remainder 1 over the denominator. So that's 3.5. So let's do that again for number 2. Numerator divided by denominator. So 3 into 5, we can only get one set of 3's in 5. So that's 1. We'll have a remainder of 2 because 3 plus 2 is 5. And we must put back the same denominator. So 5 over 3 is equal to 1 2/5. So you can try the other questions now. Okay, let's correct. So here we have the answers. Multiplication of a fraction by a whole number. Exercise 1. So what some persons do is put the whole number over 1, which is fine. So we check to see if there's any number that can go into a denominator, and the same number can also go into the into a numerator without a remainder. So let me say it again but differently. Is there any number that 3 and 15 can be divided by and not give a remainder? Yes. 3 into 3 is 1 and 3 into 15 is 5. So no remainders, so we can do that. So once there's no other number that we can divide a number on top and a number below by, then we can multiply across. So 1 times 5 is equal to 5, and below we have 1 times 1, and some persons put is equal to 1 and then they put anything divided by 1 is itself. So 5 divided by 1 is 5. Right? If we are dividing by 1, you can just leave 5. Okay, let's look at number 2. Actually, let's look at number 6. So we have 2 here and we have 5 and 10. So we can only divide a number on top with a number below. We can't do two numbers on top. So what can go into both 5 and 10? We know that there are no numbers that can go into both 2 and 5 without a remainder. So for 5 and 10, 5 can go into 5 and 5 can go into 10. They are both divisible by 5. 5 into 5 is 1, 5 into 10 is 2. So we can put this over 1, and we can say 2 times 2 is equal to 4, because we can't do any further cancellations. And then we have 1 times 1 is equal to 1. 4 divided by 1 is still 4. So let me do another example. So let's say we have 2 over 6 multiply by 5. So once it's one number on top and one number below, we can divide by the same number. So we can cancel on top and below even if it's vertical. It doesn't have to be diagonal. 2 into 2 is 1 and 2 into 6 is 3. So 1, now that we reduced all we can say 1 times 5 is 5 and 3 times 1 is 3. We can change that into an into a mixed number if we like. 3 into 5 is 1, remainder 2. So that's 1 and 2/3. So let's do one more. Four into 4 is 1. 4 into 16 is 4. We can't cancel or reduce any further, so we multiply across. 3 times 4 is 12. That's 12 over 1, which is still equal to 12. So you can try the rest of the questions now. Remember to pause the video. Let's look at the solutions. Okay, next. Dividing a whole number by a fraction. So this has some similarities with multiplication. So what we need to do is change the division sign to a multiplication sign and flip the divisor. What is the divisor? It's simply the number of fraction we are dividing by. So if a question is written like this, it's the fraction or number on the right of the division sign. So that will be 12 change the sign to multiplication and flip, or some persons say invert or reciprocate the divisor. So that's 4 over 1. So 4 times 4 is equal to 48. 48 over 1 is still 48. Okay, let's look at another question. 20 divided by 5/6. So 20 multiplied by 6 over 5. 5 into 5. So now we basically have a multiplication question. So 5 into 5 is 1. 5 into 20 is 4. So we cannot reduce further. So we say 4 times 6 is 24. And 24 over 1 is still 24. So this here would have been 20 over 1. And 1 times 1 is 1. So 24 over 1 is still 1. Sorry, 24 over 1 is still 24. Okay, so I think that you all understand. So go ahead and try the questions. Okay, let's take a look at the answers. Alright, so let's take a look at multiplication of fractions by fractions. So can 5 go into 24? No. Is there any number that can go into 5 and 24? No. Similarly, there's no number that can go into 4 and 15. So remember, it's not only diagonally we cancel, but we can also reduce the fractions, meaning cancel vertically. So let's see if we can do that. What can go into 5 and 15? Yes, 5. 5 into 5 is 1. 5 into 15 is 3. And 4 into 4 is 1. 4 into 24 is 6. So 1 times 1 is 1 over 3 times 6 below is 18. Number 6. Actually, let's do number 7. So we can go this way. We can say 6 into 6 and 6 into 18. Or we can say 2 into 6 and 2 into 14. All of these are even numbers, so we have options. So I would prefer to do 6 into 6, so we can get rid of the 6. 6 into 6 is 1. 6 into 18, 3. 7 into 14 is 2. 7 into 28 is 4. So we can even go further. 2 into 2 and 2 into 4. 2 into 2 is 1. 2 into 4 is 2. So now we multiply across. 1 times 2 is 2. And 1 times 3 is 3. So the answer is 2/3. So go ahead and try the rest of the questions. Okay, let's correct them. Oh, we don't have the corrections as yet. So I will have to do that in the next video. Okay, so division of fractions. So we'll begin with number 1. So remember, when dividing fractions, whether it be by a whole number, or dividing a whole number by a fraction, or dividing a fraction by a fraction, we must flip the divisor and change the division to multiplication. So that will be 12 over 15 multiplied by 20 over 4. So the best way I'm seeing to reduce this, or to cross multiply, is by saying 5 into 15 is 3, 5 into 20 is 4. We can say 4 into 4, 1, 4 into 4, 1, 3 into 3, 1, 3 into 12, 4. So now we have 4 times 1 on top, which is 4, and below we have 1 times 1, which is 1. So 4 over 1 is still 4. Okay, let's do another question. So we will put back the number we are dividing by, which is also called a dividend. 14 over 22. We change division to multiplication, and we flip the divisor. So right away we can see that 11 can go into 22. So 11 into 11 is 1. 11 into 22 is 2. There is no number that can go into both 5 and 14. So we say 1 times 14 on top is 14, and below 2 times 5 is 10. Okay, so I just realized there's an example I didn't show you all. So let me do that now. Let's say we have 3/5 divided by 4/7. So we keep the 3/5, we multiply by 7 over 4. Now there's no number that could go into both 3 and 5, or both 3 and 4. Neither is there any number that can go into both 7 and 4, or 7 and 5. So there's no way we can cancel or reduce these fractions. So we multiply across. 3 times 7 is 21 over 5 times 4 is 20. Let's look at number 5. So when we have a mixed number or mixed numbers, when dividing or multiplying, we must change them to improper fractions before we begin. So remember, to change this to an improper fraction, we say 1 times 5 is 5 plus 4 is 9. So that's 9 over 5 multiplied by 2 times 10 is 20. 20 plus 7 is 27. So remember to flip, so that's 10 over 27. So let's cancel. 5 into 5, 1, and 5 into 10 is 2. 9 into 9 is 1. 9 into 27 is 3. So on top we have 1 times 2 is 2. And below we have 1 times 3 is 3. So the answer is 2/3.
Thank you for watching. If you have found this video to be helpful, please feel free to contact us for more information about our classes.